An enduring memory of my childhood was taking walks on the beach with my father and my sister. And like many children, what I did was pick up seashells. Seashells are fascinating. Not are they only made of nature's original structural material. Seashells allow lots of CO2 to be held within them in the form of a solid. Seashells are nature's natural means of holding carbon dioxide within the form of a solid material. At the Institute for Carbon Management, this is something that we've spent a lot of time thinking about and looking at. These natural processes, if they can be transformed into engineered processes and engineering systems, can allow for very large-scale carbon removal from the atmosphere that is fundamental to limiting climate change.
Carbon Belt is transforming concrete from one of the largest global emitters into the world's largest productive carbon sink. Our capital-light, X-Prize-winning approach uses waste materials to reduce concrete's carbon emissions by 70 to more than 100%. And we're preparing to quickly and profitably deploy our technology at thousands of concrete manufacturing plants worldwide.
We are developing a membrane that's going to enable the clean and sustainable production of lithium, which we extract from brines such as saltwater. This will increase the availability of this critical battery metal.
The high cost and difficult access of lithium, which goes into batteries that power electric vehicles and mobile devices, presents a real difficult challenge. With Specifix's portfolio of clean, affordable, and scalable technologies, we can access domestic resources for lithium and bend the cost curve, thereby making it more affordable to charge electric vehicles and mobile devices.
Traditional thermal processes for carbon dioxide capture are very expensive and energy intensive. In our lab at UCLA, we're working on a process that combines electrochemistry and membrane-based technology. This is an energy and space-efficient process for the capture or utilization of carbon dioxide.
I think a fundamental principle and fundamental mission concept around which the Institute for Carbon Management works every day is based on how do we really continue to maintain, accelerate, and improve our quality of life without inducing further harm to the environment and reversing the damage that we've caused.
If concrete were a country, it would be the third largest emitter of greenhouse gases on Earth, only behind China and the US. So in our lab at UCLA, we use artificial intelligence to discover new concrete formulations with lower carbon emissions.
We embed data-driven efficiencies into concrete design. This ensures a significant reduction in carbon emissions as well as cost of production. This process is revolutionizing the concrete-dependent construction industry and will ensure that building materials are far more sustainable in the future.
With Sea Change, we've developed a transformative approach to carbon dioxide removal that uses the ocean's natural ability to absorb carbon dioxide from the atmosphere like a sponge. Then we use electricity to stimulate a cyclic process that permanently locks away the carbon dioxide without upsetting the ocean's natural ecosystem.
To power the green economy, Aquatic leverages seawater electrolysis technologies to remove carbon dioxide from the atmosphere while producing green hydrogen. And we're able to do this at the lowest possible cost to enable the transition to carbon-negative economies globally.
At the end of the day, what makes a career worth it, not only for me, but for the team that I work with, is the ability to work on a defining problem, the mitigation of climate change, not only for today, but for generations to come.